And today's session, I think, is quite exceptional. It's a very technical topic, and I think we have a good cohort of panelists. Most of y'all who I know personally, I've seen your journeys collectively for us as a green hydrogen industry. The last 3 years, it didn't go the way we all wanted to, right? And there are collectively a lot of issues that we are addressing together. We'll continue to do that as one whole ecosystem in India. And I think electrolyzer manufacturing as part of this whole mix is going to be very crucial. India is not looking to produce electrolyzers only for itself, but also export to the rest of the country. And I think there are some challenges before we reach full indigenization, and that has a lot to do with, whatever the topic is here for today. So, without further ado, thanks for everyone who joined us. Let me begin by introducing the panel, and I'll give it over to our moderator, Santosh Gurunath. Santosh, perhaps if you're there, perhaps you could introduce your panelists and then take over.
Sure, Nishant. Thanks a lot for the kind introduction, and thanks a lot for organizing this. It's very important topic, and yeah, I mean, I'm sure that we'll have a great afternoon talking about an important element of the electrolyzers, which are the membranes and the catalysts, right? So in terms of our panelist, is Parth, are you sharing some screen or something, or is there any way we can do it? Or so in the meantime, Parth shares a screen. I mean, we have been joined by a wonderful set of panelists, right? I mean, right from the industry who are very much in the forefront of, let's say, electrolyzer manufacturing, right? So we have with us Mr. Siddharth Gupta, who is joining us from L&T Electrolysers. So L&T, we all know, has been playing one a key role in the hydrogen ecosystem, and with the recent award of the tender of for IOCL, it is going to be a very important and a good next step as well. We have Mr. Gonzalo Abellan joining us from Matteco, and he'll be talking about let's say membranes, and he'll be talking about so post this call he'll be giving a more comprehensive introduction about himself, as well as talking about some of the developments in the membrane ecosystem. Then we have been joined by Mr. Dr. Prasanta Sarker. He's from Newtrace, a good friend. We are building state-of-the-art electrolyzers based on, and one of their key propositions is to see how they can get around this, let's say, rare earth metals. So we'll hear a lot about them. And Prashanta and team has been doing some excellent work over the past few years, building completely indigenous systems and trying to see how they can reduce the cost of electrolysis and taking a very different approach, right? From it. And finally, I think we'll be joined by Mr. Siddharth Mayur as well. We are waiting for him to join the call. But Siddharth Mayur is the co-founder of H2E Power Systems, and they have been one of the pioneers in the hydrogen ecosystem in India, and have been involved in all the early stage projects. And right now, they do everything right from electrolyzers to fuel cells, and to doing a lot of pilot projects in this front as well. And I'm Santosh. I'm the co-founder and CEO of H2 Carbon Zero. We specifically look at hydrogen fuel cells, looking at stationary power applications, and have been also, in addition to that, also working together with Nishant to spread awareness of green hydrogen and supporting the ecosystem at large, in the development and early development phase.
Thank you so much for the introduction. So, as you mentioned, Matteco is a Spanish company. It's located right now in Valencia, close to the Mediterranean Sea. And what we are characterized because we try to be at the forefront of the next generation catalyst for green hydrogen production, with a special focus in alkaline technologies. Alkaline technologies could be traditional alkaline electrolysis that use high pH concentrations. And also there is a new technology called anion exchange membranes, in which, in contrast to the conventional technology that use separators, now with the new technology AM, the people are using membranes, most of them from an organic chemistry origin. So what we are trying to make is benchmark catalyst for both technologies, and also final electrodes just to plug and play using non-PGM catalysts. I will comment more on this later. So going to the technological background, if we think in the heart of the green hydrogen production process, so these electrolyzers that I mentioned, that the alkaline ones, the final idea is that they will be operated using renewable sources like solar panels and so on. And if we go inside the one cell, for example, the one you can see on the right part of the slide, is a single cell of an anion exchange membrane electrolyzer. So the main components and the ones in which we are focusing at Matteco are the cathode and the anode. Yeah, they are labeled as D and F, and the letter E will be the membrane in this case, or a separator like siphon, for example, in the conventional electrolysis. So the idea is that these machines will be able to by means of electrolysis, to split water in hydrogen and oxygen. And why is the production of hydrogen important? I think in this forum it's not necessary to spend much time on that, but sometimes it's good to recall some figures, because the challenge is immense and the opportunity also. So for example, if we want to decarbonize the economy, what we know from the data, from the official data, is that hydrogen can contribute up to eliminate or abate 6 gigatons per year of CO2 emissions. That's more or less the expectations up to 2050. But also at the same time, it has a component more related to geopolitical aspects, is because it is one of the energy vectors that are called to be critical in reducing the independence of some countries about the energy imports. So for example, if we focus in India, say over 40% of the today India energy is coming by external sources. And regarding the emissions, so we have to take into account that it's not just a matter of thinking in producing, for example, cars using hydrogen or things like that. We are going to the basics. For example, just only one process, the production of fertilizers all over the world, emits more than 28% of CO2. So, and this is a process that can be easily transformed into a green process by using green hydrogen. Also, steel is another big process, fundamental one that we can think of. So the opportunity is immense. And what is the value proposition that we want to introduce in the market? Is that using catalyst that doesn't contain PGM metals, so platinum group metals, so these 6 very expensive and geolocalized metals, we will be able to have high performance electrodes that will allow us to reduce around 20% the production cost using some of our patents. And why is this so important? Because we know that the objective, the target levelized cost of hydrogen by 2030 is expected to be around $2 per kilogram. And right now we are around 5. And that's one of the barriers that are blocking the development of hydrogen at the speed that we want. And also regarding the PGM metal, so here you can see a slide, what is the origin of most of these very scarce and expensive metals like palladium, platinum, iridium, ruthenium, and so on. So we are not using any of them because this will allow us to reduce the price, to have a good performance, but also to keep independent from the energetic point of view. So our solutions rely on different aspects. So as I mentioned, no critical raw materials, because most of our solutions, for example, for the anode, are based on nickel and iron. And also we focus on the industrial scale supply, because we use a state-of-the-art patented proprietary nanotechnology that allow us to produce in large dimension, in an efficient way, electrodes with high performance. And also we are quite flexible in terms of formats and sizes. We produce catalyst powders because some of the technologies, like for example AM, they require powders to mix with ionomers and putting them on top of some substrates. But also we have a proprietary catalyst coating, and we can even grow our catalyst in strange formats, not just the standard ones with 3-dimension, with hierarchical porosity and things like that. So our performance is quite good and allow us to reduce the energy consumption up to 30%. You will see later with some data, but also allow us another aspects that will be taken into account in the next future is working with the electrolysers at very high current densities. So we can work at very high current densities, so amperes per square centimeter, that right now they are not using the commercial electrolysers nowadays. So they are a window for the future for the development of better machines. And also a very important aspect. So we got very good stability that will allow us to have long operation periods. So let me show you very briefly 3 examples of the different substrates in which we put our catalyst. So for example, you have nickel foams, which are, they have a kind of very open porous structures, very interesting in terms of performance. We also are working with nickel fibers. They exhibit different mechanical properties, but in terms of performance, they are excellent. And also there are more robust nickel meshes that they exhibit a less surface area, but more mechanical, stronger mechanical properties. In any case, we managed to adapt our technology to grow our catalyst or deposit our catalyst, improving a key aspect, which is the electrochemical surface area, which is immediately translated in good performance and good kinetics of operation. So if we take a look to one of the cells, let me check if it's working now. So this is a standard cell for IM. If we make a focus in one of the electrodes, you will see 2 colors. The gold color is our catalyst, and if we make a zoom, you will see one of the typical structures of the catalyst we patented.
Oh, nice.
What you will observe is the split of oxygen and water. And then I want to start with something quite fundamental. So for example, a long time ago, in 2012, there was an initial paper in Science in which a group from Lausanne demonstrated that using a very old family of catalysts called hydroxides, layer double hydroxides, consisting of iron and nickel, it was possible to split water and in a very efficient manner, overpassing the performance of iridium oxide, for example. So the problem is that was a very interesting discovery, but remained at the lab scale because the typical synthetic process for obtaining this very active catalytic phase they were limited to milligram scale. So they need argon atmosphere, high pressures, high temperature, and very dilute concentrations. The maximum 15 millimolar concentration of the metals. So that means not scalable conditions to obtain big amounts. So what we discovered a long time ago, we patented in 2021, is a way of making the co-precipitation, that's the synthesis of these materials, with a completely different perspective, not using an increase of the pH using urea or KOH or NaOH or things like that, but using a nucleophilic reaction, a reaction that is very typical in organic chemistry, in which we have an epoxide and we have a nucleophile that attacks the epoxide, breaking the bond and liberating OH progressively. Using this technology, we managed to make at room temperature, at atmospheric pressure, and at very high concentration, so we make the scale, the volumetric scale or the mass scale, both working quite properly, and we managed to synthesize huge amounts of the catalyst. So you can see there the picture of one of the first syntheses, 2 kilograms of the catalyst. That was insane at that time. Now we are able to produce over 20 tons of this powder per year. So we have this capacity. We are not producing this amount right now, but if it's needed, we are capable to produce up to 20 tons per year so far. And what we demonstrated is that this technology is so mild that we were able even to synthesize the catalyst inside a synchrotron. And why this is important? To demonstrate by means of SANEX, XAFs, or SACs that we are able to synthesize a genuine layer double hydroxide phase even in this mild conditions. Of course, with a poor crystallinity, as you can see in the figure A, the blue line is the powder X-ray diffraction of the catalyst compared to a standard hydrothermal route that you can find in many, many papers all over the world. So, but when you go to SANES and EXAF, what you can observe is the typical fingerprints of the nickel iron LDH. Also in XPS, we demonstrated that the oxidation states and the interlayer anions were the expected ones. And very interesting is that we observed that our catalyst, it exhibit this poor crystallinity because the particles were nanometric, were very small, and the crystalline domains were small, but also because of a very interesting phenomena that is key for the good performance, which is the iron clustering, so the 3-valent metal clustering that was reflected in a fingerprint pin peak, as you can see in figure H, and also confirmed by Mossbauer spectroscopy. All these stories that are very interesting are more impressive if you observe in real space. So what you can see here is scanning transmission electron microscopy coupled with electron energy loss spectroscopy. And here you can see that this clustering is even visual in the microscopy. So on the right side, you can see a standard, a normal layer double hydroxide, and on the left side, you can see that there are green areas and red areas. This separation of the metals, this heavy cluster, was predicted by DFT plus Hoover simulations to be very, very active, reducing the rate determining steps. That was also reflected in rotatory disc electrode experiments. But when we jump from the lab to other techniques to prove that the clustering is making an impact, for example, I like a lot to show that the behavior in Raman spectroscopy demonstrates what is the main difference between these two catalysts. So on the left side, you can see our patented technology in which the peaks of the layer double hydroxide converts completely to the gamma nickel oxyhydroxide, which is the real active phase under operation conditions. On the right side, you can see what happened to a standard LDH, a plethora of different peaks and not a complete conversion to the very active phase. And this conversion is crucial. So for example, if we make electrodes using an automatic spray coater at different stages, rotatory disc electrodes in the lab, 3 electrode cells in the middle, and a single cell like the one you can see in the picture with more realistic conditions, we can get wonderful performance at all the different stages using our catalyst. This performance exhibit a superior overpotential and an impressive Tafel slopes of around 40 millivolts per decade. That is very, very interesting. And also we performed some stability studies, this in collaboration with the Higher Institute in Germany, using commercial membranes. And what we observe is if you compare our patented technology with the standard benchmark in the literature, the performance is much better and also the stability. In terms of impedance spectroscopy, that means in the resistance, but also a very interesting aspect. If you measure Raman at very high current densities, 500 milliamperes per square centimeter, we observe a complete transformation to the gamma phase, a thing that is not happening in the normal LDHs, but also more interesting in SANES, we observe that the nickel reaches higher oxidation states in our catalysts compared to the standard ones. So all together allow us to have a very robust technology with an unprecedented performance. So that's fine, that's a paper, but if we jump into the hardcore technology, so for example, jumping from the anion exchange membrane to conventional alkaline electrolysis, that means 7 molar KOH, higher temperatures like 80 degrees, 70 degrees, 65 degrees, bigger cells, in this case is a 5 square centimeter. What we can reach is a performance at 1 ampere per square centimeter. Remember here we are using Sirfon diaphragms of 500 microns at 1.84 volts, which is quite good if you compare to other alkaline technologies. For example, if we test this with an independent institution, in this case, Hayern in Germany, they even managed to analyze the performance at very high current densities. As I mentioned in the introduction, you can operate under alkaline conditions up to 3 amperes per square centimeter, getting values that are quite competitive with, for example, AM, but using conventional alkaline electrolysis. Or even more, if we are using a full setup without non-PGM cathodes, so for example, using a nickel running, you can obtain, for example, 1.84 volts at 1 ampere per square centimeter. So this is reflected in very good values of efficiency in terms of energy. Or other point, so what is the degradation? No, so there are different ways of studying the degradation of these electrodes, but if we focus, for example, in 3 electrode setups, just focusing on the very electrode, one of the ways to analyze this is making accelerated degradation test or accelerated stress test. So here we show you, these are linear sweep voltammetries after making several cycles of accelerated stress test, showing a very competitive degradation after several cycles. So these tests are still ongoing. Those are tested by ourselves at Matteco. And also, for example, with our second generation electrodes, we can reach degradation with very low values of millivolts per hour after the initial stabilization, which is happening typically in the first 20 hours. So this is good, but probably it's even better when you see some tests developed by independent institution, and in this case is one of our customers, in which they observe even better performance than ourselves when they have optimized devices. So here you can see around 1.9 volts at 2 amps per square centimeter, and degradations that are excellent after hundreds of hours. But the interesting part of this test is that they make polarization curves, then static holds, then several cycles over 24 hours, and also accelerated stress test, and then measuring again polarization curves. So this gives you a hint that these anodes will survive for long time in real operations, which will be less aggressive than that. But before going to the last part, I want to show you, for example, an interesting aspect that is now one of the key points in degradation in everyone that are working on electrodes so far. So it's what happened with the aggressive shutdown simulation. So because if we want to operate this with renewable sources, what we expect is that several hours, not seconds, not minutes of shutdowns. And in this case, what we know is that inverse currents or the channel currents are affecting heavily those electrodes using innovative catalysts. So what we obtain is very stable and very robust anodes that will survive heavy shutdowns of 12 hours without any problem, and with a degradation that is almost absent in the hundreds hours periods. So we are still running all these tests with our new electrodes, but they are very promising. So in summary, what we can say is that with the different contributions, so for example, reducing the surface area, so increasing, the surface area, and also avoiding the use of PGMs, and getting very stable electrodes that will reduce the maintenance cost of the recatalytic process in the future, and also a very high over potentials, altogether will allow us to estimate a reduction of 20% of the levelized cost of hydrogen. And yes, I want to show you very briefly what is the origin of Matteco, because Matteco started in Valencia in 2012 with the research in my research team and other researchers from the Institute of Molecular Science. It's one of the few excellent institutes in Spain focused on chemistry and material science. And we developed a new family of materials in 2019, the ones I showed you before in the paper in Nature Comms, that was patented in 2021. Matteco, as itself named, with this name, born in 2023. In 2024, in October, we closed a Series A with a 15 million euro for the factory opening, and we acquired some facilities in which we will have the capacity to reach the gigawatt scale by this year, 2025. And what we want is to have and to bridge the gap between the lab very high performance catalyst and the industry. So we want to put in the market catalysts that behave as well as those that you can read on the publications at a good price. And we are quite focused on the customers. And that's the reason why we are so flexible, trying to adapt our technology to different sizes and formats, and also different substrates, not only those based on nickel. And everything that began small, like ourselves, because we were a spin-off from the University of Valencia, working in a very tiny lab. Now we will be able to expand our production to our building that is almost ready to be open by the next month. And with this, we will be able to scale up the production of our electrodes from the current sizes that we are able to deliver, those you can see on the pictures on the left, to things that are really big, up to 2 meters, and with substrate flexibility, including nickel meshes and similar substrates. The last slide I want to show you is that we are involved in many research and development projects with several partners. And one of the projects that is very exciting and we are working now is the development of a PGM cathode that is able to operate in the very same conditions I showed you before. And we have an excellent team. And I want to recognize today, especially Dr. Somesdat Sharma, which is our wonderful country director in India, which is helping us a lot to introduce our technology in India. And we believe that this is an excellent opportunity for the near future. So thank you so much.
Thank you. Thank you very much, Dr. Gonzalo, for the wonderful presentation. I think pretty remarkable the work which you have been doing as a team. So I think looking at the time, we can quickly move into the panel discussion part. If you can please share the panel discussion screen and put others in spotlight, we can get started. So in the meantime, I get everyone in spotlight, Dr. Gonzalo. First quick follow-on question, right? I mean, before I move on to the other panelists and have a general round of discussion first. So a lot of your setup which you have been installing or which you have been testing so far, are there any deployments which have been done on the commercial level? Are there any live projects which you are doing, for example, where you are supplying these to the likes of Tyson's and Siemens, etc.? We saw glimpse. Would be great to understand a little bit more about that.
Sure. So good question. So we started making first analysis at the lab scale. Then we make some analysis in single cell or short stacks, which are very interesting in-house and also in third parties. As you can imagine, most of the data of our customers, we cannot share it openly, and we share what we can share, no? But for example, some of the data, the last ones I showed you, are developed by customers, so third party independent, and will be integrated in real stacks that will be hopefully commercialized by the next year.
Sure. Thanks, Mr. Gonzalo. I think we'll come to you. Again, once again, introducing our panelists, Dr. Prasanta Sarker and Mr. Siddharth Gupta. And to get started, I would like to request both, starting with Mr. Siddharth and then Mr. Prasanta, to give a very short introduction about what you've been doing in the electrolyzer space, and specifically perhaps touch a little bit upon the catalyst side as well, and then we can get into the discussion. So I did give a short introduction in the beginning, but then I think now we have a larger group, so it warrants a short introduction from our side as well. So Mr. Siddharth, if you could go ahead first, and then Prasanta.
Yeah, so thank you very much, Santosh, Nishant, and GH2 India for giving me an opportunity. A very warm welcome to sort of everyone here as a part of the panel discussion, and to my co-panelists. Wonderful presentation, Gonzalo. It was a pleasure to see the presentation. So I am representing L&T Electrolysers, and we are into the pressurized alkaline electrolyzers. We have a production facility in Hazira in the state of Gujarat, which is very close to the city of Surat in the western part of India. And we already have a capacity of 400 megawatt, which is operational. We have sort of indigenized the electrolyzer to the extent of 85%. The entire value chain has been developed by us over the last 1.5 years, and I think that is a tremendous work which the team has done here. In terms of, we already have 2 contracts, one of which we have executed, and the second one is under progress right now. So both the stack and the electrolyzer processing unit are being manufactured by us in-house, which is the sole credo of L&T, as a part of the Make in India initiative. So, Santosh, you had mentioned some
Thanks.
other point also to be.
No, we'll come back to that, Siddharth. I think
Okay.
Mr. Dr. Prasanta, short introduction about you and Newtrace.
Thank you, Santosh. Very good to see you, and Nishant. Thank you, GS2 India, for having me here. My name is Prashant. I'm the co-founder and CEO of Newtrace. Newtrace started 5 years back. We're based out of Bangalore, and we are an end-to-end technology company which started with the development of membraneless electrolyzer, the view of not using a membrane and yet delivering pure hydrogen and oxygen. Until now, we have done pilots with some of the oil and gas PSUs. Our deployments are ongoing. In our development of membraneless electrolyzer, we have worked across different electrode substrates and electrocatalyst development for the last 5 years. As a company, we have over 5 different patents that we have applied globally on electrocatalyst. As Nishant was talking about the market scenarios and the current first trend towards alkaline system and the time taken for our systems to get validated in industrial setups. From early this year, we started piloting on high performance electrocatalyst for alkaline systems as well. And we currently have electrodes ranging from 220 centimeters squared to around 5,000 centimeters squared surface area being tested in our technology center in Bangalore, getting ready for the 1 megawatt scale up by the end of this year. And the idea is to have performance data very similar to the best in the industry, as well as the ability to operate at high current densities for very specialized high performance membrane based stack that we are also developing. Our focus is, as we started without the membrane, our focus is on the non-PGM activities. So we always develop non-PGM, non-CRM electrocatalyst, and that's one of the new development that has happened in Newtrace while the membraneless part is still under validation and scale-up activities.
Thanks a lot, Dr. Prashant. So the first question I think applies to basically all of you, and first I'll request Mr. Siddharth to share his opinion, and then the rest. In terms of the supply chain, right, of these equipment, and specifically the electrodes, right? And so, Mr. Siddharth, you are looking at it from a pressurized alkaline viewpoint, and Prasanta and Gonzalo, both alkaline as well as AEM electrolysis. So, Mr. Siddharth, like, how are you looking at it from the supply chain of these electrodes and membranes? Is that a major challenge to get those in India? Are we manufacturing them locally? So, at a macro level, what are the supply chain challenges what you are facing right now?
I think from a supply chain management perspective, as I mentioned to you, we have indigenized to the extent of 85% already. Now, when we say 85%, the only items which at the moment we are importing is the membrane. And primarily because there is no membrane manufacturer in India for our type of electrolyzers that is being made. The second aspect is the catalyst coatings and the raw material for the catalyst coatings, which is again primarily nickel based, is again I'm talking from a raw material aspect is only imported. Otherwise, we've developed the vendor base in the country, and naturally there are these small vendors. The issue from a supply chain management perspective is, which I've been mentioning at various forums, is that typically, if you see countries which have a very high manufacturing percentage to their GDP, which is, if you talk about China, which comes at somewhere around 25% or so. The point to be noted there is that if they are talking about an electrolyzer capacity base of hypothetically, 10 gigawatts, then the backward integration also in terms of the vendor base for that technology is also to that similar extent. So what really happens is that you have a commensurate vendor base in that country, which can cater to the overall capacity that the country has planned for. Whereas I think the government of India, let us not say it otherwise, they have taken a lot of initiatives. The National Green Hydrogen Mission, in terms of the PLIs, a lot of things have come up. But I very strongly feel that, if today we have to execute, L&T's got the order for IOCL 10 KTPA green hydrogen tender. And if I have to manufacture this 100 megawatts of electrolyzers, then do we have that commensurate capacity in the country in terms of the vendor base? I have a capacity of 400 megawatts, but in terms of the vendor base, I think the capability, the skill development, the scalability are some challenges which definitely need to be addressed.
Okay. Thanks, Siddharth. I think that's a very relevant point, and I think that's where I'll bring in Dr. Gonzalo. And one of his activities has been to use some of these PGM materials. So, Gonzalo, when you are looking at setting up a base, for example, as a manufacturing facility potentially in India as well as in Europe, what are the supply chain challenges? I mean, you have mentioned that you're taking a very much PGM-free approach that makes it easier for you. But even beyond that, are there any specific challenges? Are there challenges on the material side? Are there challenges on the machinery side through which these coatings can be done? So how are you approaching that, and how are you solving for those as you scale up to a gigawatt?
Sure. There are different challenges with different levels of complexity. In terms of the metals that you need, so probably the situation is quite similar to Europe. So if you want to produce in India, if you are using any kind of complex PGM, the typical sources, what they are. So, but I think that the main challenge could be in terms of one of the components that you have to have in place, for example, the substrates. So you cannot find the right substrates in the right dimensions in every country. And in terms of supply chains, this impose some challenges that you have to overcome to produce in China in an efficient way. So this is something that is coming immediately to my mind. And of course, the other aspect is the machinery. So if you need a special production line, which should be automatic with some specific technologies, sometimes you need to go to a few producers that are located either in Europe or in China, and I think this will be one of the big points to overcome in the future, to be able to produce this in the country and to be able to reduce the cost of importing all these technologies. Probably not in the short term, but I will put this as a kind of flag for the future.
Got it. Thanks, Gonzalo. I think, and Prasanta, I mean, you mentioned your, let's say, diversification to a certain extent from membrane-free electrolysis to electrocatalysts, and you've been building in this space over the past, let's say, good 3 years in India. What has your experience been with respect to supply chain of various parts of the ecosystem, specifically around these components?
Right. I think in terms of the components in focus right now, the membranes, currently I'm not aware of any producers in India. I think most of it is currently coming from global sources. And I think that's going to be a key challenge for everyone who's going to scale up production, particularly in the membrane electrode world. In terms of the electrode development that we have been doing, we were fortunate to do the whole development process ourselves, and as a result, we recently commissioned the electrode coating and production line in our facility in Bangalore. And with the substrate that we use, which are very similar to the conventional alkaline system, although there are very few vendors, but we are confident that the entire value chain can be localized in India, starting from the substrate, and the catalyst component is all locally available. If you're looking at volumes and price competitiveness, which is a very key factor in the Indian market, then probably the cost of substrate and the supply of substrate from markets like China will be a critical factor, because I don't think the current volume and cost in the Indian market can match with the Chinese market and substrate. But I think with more and more activity on the ground, we will see more developers more vendors coming into the ecosystem to supply these substrates. with the volumes coming in, and as a result, we can completely indigenize. At least the electrode part is what I fundamentally believe. The membrane part still looks very, very difficult in terms of the complexities in the production process.
Got it. Got it. So expanding a little bit from supply chain to the technology choices which is being made, right? And keeping the discussion a bit more wider. Gonzalo, you are looking at AEM and alkaline. Siddharth, you're looking at alkaline, and Prasanta, you're looking at membraneless. Somewhere between alkaline and AEM. The question to all of you, and I think I'll start with Mr. Gonzalo, is there any specific reason for you to look at building these catalysts specifically for alkaline and AEM? And is there a potential to also use non-PGM based catalysts for PEM electrolyzers? And PEM electrolyzers, given the let's say applicability of that in Europe quite a bit, given the dynamic and intermittency in terms of RD matching and temporal correlation, is that something which you're also looking at? And secondly, what is the specific reason for going after alkaline and AEM as a target market in your case?
So first, so you mean to use PGM-free catalyst for PEM market?
That's the question, yes.
So we are aware that there are a couple of advances in this direction, but I will say that they are still far away from the market. So I'm aware of a couple researchers that are getting nice results in this, and I can imagine the way it will happen in the future, but I will say that it's nothing that will come in the next 5 years, probably. So unless something hidden happens, and you never know. But in terms of the deployment of AM for the future, what I see is the contrary. So 2 to 3 years ago, it was a kind of niche technology with a limited scale-up perspective. But there are many companies exclusively focusing on AM right now, that they are not developing any more stacks for alkaline, just focus on AM. And there are different membrane suppliers that are able to make membranes that are more robust under alkaline conditions than the previous ones, and they are increasing the sizes. And this increase in the size, it will be a kind of quantum change, because as soon as you can introduce a kind of roll-to-roll process into these kind of membranes, I think that the prices and the performance will be much better, and then the price of this technology will improve a lot. And the possibility of operating AM at more than 2 amperes per square centimeter, it will not be a kind of chimera anymore, and that will make a change in the price. So I'm quite optimistic with AM.
Got it. Thanks for that. And Mr. Siddharth, from an L&T perspective, your technology choice has been pressurized alkaline. And how are you looking at it going forward? Is the choice or availability of some of these electrocatalysts one of the reasons to go for alkaline over the other, over PEM or AEM, or are you also looking at some of the other technologies, AEM, which Gonzalo, for example, is pretty optimistic about?
Well, from our perspective, we went for the alkaline technology as it was the most mature technology. Second, in terms of if you see the scale, we felt it is possible to upscale it and to sort of take it ahead. The third aspect is availability of the non-PGM materials, or the non-noble metals are typically used here in terms of the electrodes, the coatings, which we felt is also sort of a criteria which has an impact on in terms of availability as well as in terms of the costs. So these were sort of the 3 main reasons why we went in for the sort of the pressurized alkaline technology. And we at least feel sort of for the next 3 to 5 years that this technology is here to stay. We are also evaluating the other technologies, but at the moment we are fully concentrating on developing a gigafactory for the alkaline technology.
Thanks. Prasanta, your take on the technology choices and how you see things moving forward.
Sure. I think our activity on the PGM-free electrodes for alkaline was an extension of our work on the membraneless alkaline system, for which we were developing a robust electrodes, which were doing all the separation activities for us. And as a result, we've felt at least the developers were looking at alkaline technology because of the maturity of the platform and the decades of operating experience that the platform has in terms of reliability. And I think that's where we felt in terms of commercialization, we could actually make a electrode for the alkaline system much faster. As a company, we have not done a lot of work on PEM electrolyzers. So in our view, all different platforms are very, very complex in itself. And we wanted to focus ourselves on our areas of strength and build on top of that. And I think that's where, I mean, just to share, over the last 3 years, we have done over 1,000 combinations of substrate electrocatalyst combinations to test and scale up. It's a very tedious job to kind of scout for the entire spectrum, to work on the scale up, get all the data that everybody needs for evaluation to start. And I think in such a scenario, we decided to focus entirely on the alkaline system just because of the signals that we are seeing in the market at this point in time. In terms of AEM, as I said, I think there is a lot of excitement with AEM, but there is also, I think, some years down the line, that people are still waiting for some stability data from the entire ME assembly, and it will take its own time to kind of develop validation across the use cases before large-scale deployments happen.
Sure, I think that's a very interesting insight, and I think that's where I'm going to deep dive a little bit further, right, and talk about degradation and accelerated tests. And one of the things which like comes across, right, I mean, when we are building these alkaline or building these large scale hydrogen projects is, after how many hours do you need to replace your stack, right? And it's a very important parameter, and there have been for alkaline systems typically we talk about 80,000 hours in terms of numbers. AEM, still, there have been discussions. We've heard 40,000, we've heard some 60,000 as well. So would like to spend, and I think start with you, Mr. Dr. Gonzalo. I think you showed a couple of very interesting graphs and talking about not only accelerated the degradation test, but also during dynamic conditions, right? So, I mean, how are you looking at it? How are you looking at those number of hours before which you need a replacement, and how much of that is, let's say, determined by your choice of your electrocatalyst, and what percentage comes from the operational let's say aspect around it. So, and how do you go about it? Basically, can you explain a little bit more on your analysis?
That's a super interesting question. So you know that sometimes you are not able to test your electrodes for 4,000 hours to determine precisely that what is the degradation, and then you have to mimic all this process in the short term. And then there are different strategies so some people believe that making a combination of mechanical plus electrochemical test will be a perfect reflection of the degradation. For example, using ultrasonication of the wet electrodes after operation and then making a polarization curve. That's one approach. Other approach is never remove from the electrolyte and make so heavy wide area linear field voltammetries and cyclic voltammetries, then make it on off and so on. But there is not a perfect correlation between the accelerated stress test and the real performance. And on top of that, there is another factor. So the way you operate. The other day I was in Switzerland and there was a talk from a big company showing that they realized that just the way you switch on the electrolyzer from the room temperature to the temperature of operation could affect more to the degradation than most of the conditions of operation. Only just the switching on, the way you did, if at a certain speed and a certain, so all these parameters have to cannot be taken into account for every single client. So in the end, it will be wonderful to have a kind of a standardization protocol, but all the attempts to standardize the protocol so far are failing. they are not reflecting the reality. That's the reason why the ASTs are one of the most important know-hows of the company so far. And this is the reason why the people are not sharing the way they test the electrodes. So, and I think that this is a big problem for the development of hydrogen, because this will be one of the aspects that will accelerate the speed for introducing solutions into the market, no? And that's the war we are fighting, everyone. So
Yeah, I mean, and I think like in terms of real life examples, right? So Siddharth, for example, you've been working on L&T has been working on some of these 25-year build on operate contracts, for example, and also you have what, a 400 kilowatt electrolyzer which is already operational in Azira. And how are you looking at degradation? I mean, of course, these 80,000 numbers are great to plug in an Excel sheet, but let's say, how realistic are they, and what kind of mitigations are you taking to ensure that you actually reach those numbers before you have to replace time?
So, well, I think, as we are looking at it in terms of, we have a number of test benches where, say, 1,000 square centimeter electrode is tested over thousands of hours. 5,000 square centimeter electrode is again tested over thousands of hours, and then try to arrive at where, because ultimately, see, in all these things, it's very important that you should have data. And actually, in the very nascent stage that we are in, there is no data right now. So how we have thought about it is, we have test benches. We are conducting tests. There is already a test bench where we've done, I believe, 4,000 hours of testing, and we are seeing what type of degradation is being achieved. So ultimately, there is no other way except to sort of put these electrodes and the different type of say the modifications that we are planning to a real life scenario, and test them on uh, a stack, and see how the behavior is over 1 year, 1.5 years, 2 years. That's the only way one can go about it.
Yeah, I mean, you're absolutely right, but then that also makes it very challenging for companies such as yours who are putting on a price for a 25-year contract, right? I mean, if we
Yes.
don't know what's going to happen in the next 2 years, so how
So-
do you look at that challenge?
So from that perspective, I think there is a perspective which comes in from the OEM whom we are tied up with. They have they've had a sort of these operating units. They have data with them. They've shared that data. That becomes a basis. Then we have been testing, as I was mentioning to you, for 4,000, 5,000 hours, and the could be that the sort of that was 1,000 square centimeter electrode. But typically, the behavior, if you extrapolate it to a 5,000 square centimeter or to a 10,000 square centimeter, then it's anticipated to be the same. So that is a type of correlation which we have already done. So there is a backup which we have from our OEM. There are tests which we are conducting in the test bench right now, and we have multi-megawatt test benches with us. And we are sort of correlating the behavior, and based on that, we have put in the data, and we are quite confident that we are what we have at least put in the current tenders, or what we have sort of got the contract for.
And Prasanta, I mean, as you mentioned, right, you have tested over 1,000 combination of substrates and electrocatalysts, and your proposition from day one has been very much on the membrane free, on the basically from electrode up, looking at the system which comes in later, right? So I mean, and to answer a very pointed question, how do you see these numbers, 40,000, 60,000, 80,000 hours? How real are they? Can we say something around it? And how do you, ultimately as an OEM who is supplying these electrodes, what kind of guarantees and what kind of warranties are you able to provide them, and what is the basis of that?
But I think of all the testing that's undergoing in our facility that we are doing day and night, I think one of the things is very clear that it actually depends upon the user profile of the project developer in terms of how they are sizing the whole project and how they're planning to operate the number of shutdown cycles. And so when we start our conversation with our partners, we start with the performance data that we have of different simulated conditions that we can figure out. let's say, a lot of simulation data, but then at the end of the day, you really have to find what kind of profiles are they looking at, how many shutdown cycles they're going to look into, what are the kind of current densities or nominal current densities they're going to look into, what is the ramp up down rate they're looking into. And all of that, to be very honest, has a impact on the material science. Again, I'm not an electrochemist, but what I know from all the hard work that we have done is, the more parameters that you have in the complex equation, the more degradation and effect on the life cycle that you have. And it's going to show in the product. What we are trying to do is basically find this envelope of the degradation rate, which is acceptable at the worst case scenario for the project developers. And if the operating cycle happens within the good case scenario, then actually your degradation is far less than what we anticipate. And as a technology developer, we are very, very upfront about it with our partners. And as Siddharth said, these are still early days. While alkaline is the most mature technology, but there are still early days in terms of the operation of the electrolyzer with renewable power sources. So we still have a long way to go in terms of understanding the life cycle and translating the 40,000 to 80,000 kind of journeys for different operating profiles.
Got it, Prasanta. So still early days from what I hear. But yeah, definitely hopeful. So maybe one last question to the panel before I open the floor for questions, right? I mean, looking at, and I think Nishant touched upon this really in the beginning, right? I mean, looking at it from a macro perspective, the hydrogen industry is definitely having certain headwinds right now, and there have been companies who have recently also announced kind of liquidations, and some of them we all know about and perhaps also work with, specifically Siddharth and his team. And specifically Gonzalo and Prasanta, you as component manufacturers, right? I mean, at an electrode level, at an electrocatalyst level, how are you going about these challenges, and how are you seeing your journey over the next 1 or 2 years, and when do you see these headwinds actually kind of potentially go away or turn into tailwinds? So perhaps that question first to Mr. Gonzalo and then Prasanta, and then Siddharth, I'll end with asking other question.
Okay. I mean, I think that in the end, what is probably happening is a kind of selection, no, of the projects that will make sense and the projects that were associated to a hype, to an opportunity, but not to a real curve. And this is something that is so. If we follow the Gartner hype curve, so one we pass the hype, it will be a valley of death, and then the curve of enlightenment. And it is a necessary step if we really believe that this will arrive to the market. Otherwise, so you cannot jump from the peak to the market. You need to pass this. And I think we are now exactly at this point. So we need to be patient, and we need to make projects that make sense and be realistic and resistant and resilient for the future. And that's my feeling.
Thanks. Thanks for the optimistic view, Gonzalo. Prasanta, your take.
No, I think with the ups and downs, we have to be an optimist in the industry. We all are putting in a lot of effort, and we all deep down believe that there is an opportunity and there is a lot of work to be done to address a larger problem. So we have to take the headwinds in our chins and then continue with the perseverance. I think I'm particularly hopeful with the current L&T IOCL activity and a lot of global activity picking up slowly. I'm very, very hopeful in the next few quarters, things picking up pace. And we would also request Nishant to do more for the sector to pick pace. And hopefully there will be enough activities for all of us to kind of contribute meaningfully in the sector.
And Siddharth, I think L&T, in contrast with, I think, Newtrace and Matteco, L&T has been pretty active in terms of early stage commercial deployments as well, right? And kind of everybody's looking up to you in terms of these deployments. So how do you see these headwinds, and how are you kind of looking at them and looking around them and working around them?
Yeah, so I think if you see from a broader level perspective, we were expecting that things will move faster. So, from L&T's side, if you see, we have set up an electrolyzer manufacturing facility. We've signed a transfer of technology. The amount of money which we've invested is huge. This has been there for the last, 2.5 years. the capacity with this, we have a 400 megawatt now operating unit. So we have been always sharing this with the ministry that the demand has to come up. And the first question also which you asked, in fact, I missed that point, that even if you see from a vendor perspective. So today, if I talk to vendors and I say, all the vendors typically ask that what is the horizon which you're looking at? What is your business plan typically in terms of the orders that you're saying? So that even an MSME, even any vendor, the amount of money that he will invest will be based on such kind of a business plan which is there. Now, the second aspect is, even if you talk to uh, say ACFA, which we source our membranes from, and we say, why don't you think of putting up a facility in India? Then the first question is, I mean, can you give me a picture of how the market is going to move in the next 4 or 5 years? And really, that is where the whole challenge lies. That I think the government has done a lot of things, but in terms of, say, mandates, more sort of concrete things need to be sort of pumped in, so that there are more tenders, there are more orders which go, and that is the only way that this value chain, the entire value chain, will come up. So then that is it from my side.
Thanks, Siddharth, for the encouragement, or I would say important next steps, right? I mean, which echoes more or less what Prasanta and Gonzalo were also mentioning, that we are perhaps looking at a phase where, let's say, we move from the hype to some consolidations to coming back again, right? So, and for everyone in the industry, that's going to be very important. And some of the work which all of you are doing, and Matteco and Gonzalo, which specifically highlighted, is critical in kind of pushing that ecosystem so that we can reduce the cost, increasing the efficiency and the lifetime as well. So with that, I'll open the floor for questions. If anyone has any questions, either they can type it down in the chat box or raise their hands, and then we can allow them. Vishal, perhaps you have something.
Well, no, this is a wonderful discussion, and I think we were all quite aware of some of these problems. It is a macro issue that we need to fix before Siddharth and Prasanta and Gonzalez have business on their tables. So we have a long way to go. But Siddharth, it was a pleasure having you join us. You have, in fact, if you technically look at all the order books in India, you are leading. If you take out AM Green's Kakinada order, which went to China, you've done well. And as an pioneer of sorts here, in this new age of electrolyzer businesses that are emerging, what do you think as an industry we need to do primarily, right? First and foremost, right? What is your biggest ask to industry?
I would say is my primary ask would be to promote the entities who are setting up manufacturing facilities in India. And this is the main thing that we've been reiterating with the ministry, like what happened in the thermal power sector, where you had a phased manufacturing program, and to bring in Indian sort of entities like L&T also, who came in for thermal power plants, where there was a criteria which was given that only entities can bid in tenders who have set up a manufacturing unit. That needs to be brought on the table, because that is how finally the Indian manufacturers will be sort of setting up their own manufacturing facilities and will be taking it ahead. So that is, according to me, the main thing, where we just want to say that please focus on the entities who have set up or who are setting up their manufacturing facilities, and based on that, sort of go ahead. That is something from my side.
No, thanks very much. I think you've been very vocal about this as well. And there have been fair arguments on two sides. But, from where you're coming from, I think it makes sense for, the larger Indian policy that we are trying to pursue today as, one of the larger economies in the world. Whereas Gonzalo, I don't know if you have much to add to that. You are looking to set up your facilities in India. What are your thoughts on how the market is evolving, and, what is your biggest ask?
As a good opportunity because of the market size and the possibility of having interesting off-takers that are also interested in hydrogen. So this is very, very, very interesting for us. And the main point I will ask for, I think I agree with Siddharth with what he said. So I think to establish some new areas of production with the support and probably the regulations to make it easy. That will be a key point at the initial stage that we are in India right now. So for us, that will be our wish list.
Thanks. Thank you, Gonzalo, for that. Rucha, I think you had a question. You raised your hand. Would you like to unmute yourself and ask the question?
Hi, Mr. Gonzalo. Thank you so much for the opportunity, Santosh. I've actually asked the question in the chat, but I'll reiterate. So, as Matteco develops advanced electrodes and catalysts for green hydrogen production, Gonzalo, how do you view membrane providers like Agfa, Zirfron as potential collaborators within the electrolyzer value chain, or as competitors vying for influence on the stack design and performance optimization?
Sure. Thank you so much for the question, Lucha. I mean, I see clearly as a collaborator because we are not focused on membranes. We are doing just the catalysts or the electrodes. So indeed, we are working with different companies making membranes and separators in order to optimize the interface between our electrodes and these membranes, diaphragms, or separators to improve the performance. So totally collaborators.
Thank you. Thank you so much.
So, Santosh, can I just add a point to this
Yeah, sure.
question?
Please.
Okay.
Yes,
So,
sir. Yes.
Richard, typically from, if you look at Agfa and, we've been also discussing with them what is their roadmap. So typically they are
Yeah.
also looking at, say, in the next 5 years, they're looking at membranes for much higher current densities. They are looking at thinner membranes, which will result in a lower sort of specific energy consumption because the over potential gets reduced. So, the leading membrane manufacturer like Agfa and others, they have a sort of 5-year roadmap where they're talking about these things, which aligns with actually what electrolyzer OEMs are currently thinking.
All right. Thank you so much. Thanks a lot, Siddharth.
I think
thank you.
if I may come in and add one more point here. From an electrolyzer stack perspective, it's very important that all the components sync together and perform. Otherwise, the individual components could be having its own performance. But if, let's say, the stack is not designed to operate at high current density, then the component could be validated at high current density, but they will never operate at those current density. And this perspective, we have learned the hard way because we moved from the stack to the electrode development as well. So it's important that all the components, be the membrane, the electrode, and the stack design particularly, are in sync with each other to deliver the optimum performance.
Yeah, I think
Thanks.
that's absolutely right, Prashant. I mean, typically, so that's why I think for the key components like the membranes, similarly the electrodes, it's very important that the OEM sits down along with these parties and then works out a roadmap ahead together.
Thanks. Thanks for following up that. I have a question from the Q&A box from Mr. Rahul. And the question is this, from the developer point of view, how easy or hard is it to qualify the electrolyzer manufacturers? And are there any parameters because developers don't end up contracting with not so proficient names? Perhaps Siddharth can add points to it. Of course, you have your own electrolyzer manufacturing as well, but yeah, perhaps you can add your view on that. The question is, from the developer point of view, how easy or hard is it to qualify electrolyzer manufacturers or vendors for electrolyzer manufacturers? And are there any parameters because so developers don't end up contracting with not so proficient names?
Well, so I think, the current tenders where the developers have come to us. So we submit typically a very detailed proposal to them along with the data sheet of the offering which we are giving. We've had a lot of technical discussions across the table, and where developers today also are very much aware about the electrolyzer OEMs, not only from India but from Europe, from China, and we've had very, I would say, detailed technical asks from them, wherein we've tried to justify the offerings which we are providing. The second thing is, when these developers see a facility like a facility which we have created here, which is fully automated for 400 megawatt, that makes a big difference. Third aspect is the test bench, which we have, where we are testing the stacks which we have indigenously manufactured, assembled, designed, and our testing, and we show them on a control room the data that we have offered to them as a part of the offers, that gives a lot of confidence to these developers. So these 3 or 4 are those main points, I would say, which result in confidence coming to the developers that they are coming to the right party.
Thanks. We have a question in the chat box from Achal Jain. The question is around refurbishment, right? And the question is, as there is not clarity on the degradation and lifetime, can the panel shed more light on recoating of the electrodes and associated cost and potential downtime? So perhaps Prasanta and Gonzalo, you would like to do this?
Sure. I think based on the developer's operating profile, I think there could be some estimates that could be made on the degradation rate. And the end of life is a very well-established parameter for the electrodes, which probably will depend upon the operating hours and the performance and the degradation that we are looking at. And typically at the end of life, which will happen at 10% degradation of the performance, you will have to go for a refurbishment. Now, that's a very standard definition of end of life right now. I don't know if there are economic situations which has been simulated to see if we can operate beyond that. What are the economic implication of that? But I think there's more of a techno-economic analysis that has to be done on the cost of refurbishment versus operating the whole stack at end of life.
Gonzalo, how do you look at that? How do you explain that to your clients?
Sure. I mean, I fully agree with Prasanta. That's one aspect that probably it is important, is that some companies are developing their stacks, thinking in this refurbishment. But so the big question is how you will open the stack, extract the electrodes, then refurbishing will be okay, no worries. But then when you have to reassemble again all these features, that's very complex, to the adjustment of the pressure, the electrolytes. So if the design is properly done to allow this operation in an easy manner, then makes sense from the techno-economical aspect point of view. But if they are not designed for that, it could pose some challenge in terms of pricing. So.
Got it. So moving on to the next question, I think this is in the Q&A box, so perhaps you don't have it. The question to basically all of you, what is the impact of different water sources on electrolyzer materials? So after renewable power, water source will be a critical prospect for green hydrogen production. So the question is the impact of water sources.
I think all the factors, the water sources, the impurities, the KOH purity, everything at the end of the day will have an impact on the performance of the electrode and the membrane. As far as Newtrace is concerned, we design our electrodes to be more robust, and we have seen that at least the membrane developers are more stringent on the quality of the water that has to be used than the qualification that we put in. We tend to be very, very wide in terms of our acceptable ranges of the water quality that can be used, keeping in mind the commercial applications and keeping in mind the focus of our development. So at least from our electrodes perspective, our standards are much less stringent than the membrane developers for the degradation from water sources.
Gonzalo, do you want to add something over there?
Yeah, so what we design is our electrodes are quite resistant to both the anode and the cathode, which is probably the most critical one, to the impurities. So when there is an ubiquitous impurity in all these electrolyzers, which is iron, because it's coming mainly from the piping, tubes, and so on, and stainless steel components. And so what we are sure that is that our electrodes are not contaminated, passivated, or poisoned by iron. And then depending if you are using membranes or separators, the jump of the impurities from one part, from the anode to the cathode, could be more easy or lower. But so we are trying to make it very resistant to these impurities to minimize at least our part of the electrolyzer, which are the electrodes.
Got it. Thanks, Gonzalo. We have a question in the chat box from Dr. Minat, and the question is specifically addressed to Siddharth. When will the electrolyzers, alkaline electrolyzers of Make in India? And because compared to India, China have more advanced electrolyzers with low cost. course, that's a statement. So perhaps you want to disqualify that or qualify that. But the question is around how do you compare the electrolyzers made in India versus that in China?
Yeah, so that's one of the questions which we typically have encountered in a number of meetings. I would say that electrolyzers which we are making, and on a like-to-like basis, if you compare them, then we are fully competitive with the Chinese costs. We are better than the Chinese costs, in fact, but it has to be on a like-to-like basis. When I say a like-to-like basis, it basically means that if I am putting a European membrane, then I would also, because typically each element has a bearing as far as the overall cost is concerned. So the developer or that entity also has to compare the impact of that part as far as the overall cost economics is concerned. But we have had numerous discussions on this, and we are absolutely competitive vis-a-vis the Chinese electrolyzer makers. And performance-wise, also, I would like to highlight. I mean, this was the commercial aspect. Technically, also in terms of the specific energy consumption which we are offering, we are the best out of the lot.
Thanks for that. That's quite positive. Quite let's say impressive to hear the progress which has happened over the last few years. Another question in the chat box, and then I think I'll come to Mr. Braj. So from Keithana, the question is, which industries and companies in India are currently actively pushing to buy green hydrogen, and which ones are still hesitant? So perhaps Prasanta and Siddharth, both of you have been actively looking to sell electrolyzers and perhaps hydrogen. Great if you can comment on those. Siddharth,
Well,
please go ahead.
I'll share the smaller insights that I have, and I think then Siddharth will have more insights to share. I think we have seen a lot of activity in the renewable developers and project developers, primarily who are looking to export green ammonia. The refineries are always a very curious case of what's happening there, what's next. But thankfully, the first tender has come through, and we expect a lot more activity there. We have seen also some activity on glass manufacturing and interest in the steel sector, but the use cases are still to be well validated. I think so. Those are the kind of sectors that we are focusing at this point in time.
Yeah, so I think Prasanta has covered it quite well. I mean, typically, what we are also finding, say, from an electrolyzer perspective, the various solar developers, they are getting into this area of green hydrogen, green molecules, and green ammonia. Moreover, in terms of the National Green Hydrogen Mission, now typically, your Mode 2A and Mode 2B tenders, which are there, also point to this fact in terms of the green hydrogen tenders which are there of a lot of solar companies, solar developers coming into this area. Then you naturally have these oil and marketing companies, which sort of is coming in. We already have tenders of 42 KTPA, and we are expecting another 150 KTPA tenders to come within the next year or so. So these are the sort of base and the client base which we are actively targeting as an electrolyzer OEM.
Correct. Thanks for that. We have a question from Mr. Braj. He has raised his hand, so that you may unmute and ask questions.
Yeah, sure. Good evening, Siddharth. And just when I was hearing you regarding this, the question asked by Mr. I think Mr. Minath. See, recently I have encountered one example on this. I without naming the companies, there was some companies who have supplied the electrolyzer, Chinese companies, to some EPC companies who is doing the job in India. They had taken the electrolyzer from China, brought it here, erected it. During the commissioning time, they encountered some issues. Now the phone call came to me from those EPC persons who fortunately know me. Ki, sir, we are not getting any response either on phone or email from them, and we are stuck. Please help. So with whatever small knowledge I had, I guided them, and the solution was arrived within a day. So just a pinpoint on the thing that, okay, you can get a cheaper one ex-China, maybe. I don't know. I'm not going to comment on the cost and all those things. But when the time comes for the support, you will get from within India a better one than from outside India. So that is the pinpoint. Every developer should look into it. That is my observation, and very recent observations last week only. So when I was listening to this question, answer to this question, I thought I should share my practical example just now, which I have done.
So thank you, Brajnandanji. I think you've added a point which I missed. You're absolutely right. I think this is again a very, very important point that when we have an Indian company which has an organization here, which has a operation and maintenance team here, the service aspect will be much better than rather to go to a party which is outside India. So thank you.
Yeah, because this is not a one-day job. This is a long term. You have 10 years of operation O&M, 20 years of operation. Now developers are asking for. Who are you going to catch upon later? Still
Absolutely.
the company is established in India. So that's all. Thank you.
Thank you very much.
Thanks a lot, Brajji, for the question and for your comment, right? And I think that's a very, very important aspect in terms of local O&M support. I mean, I see there are a couple of other questions, but looking at the time, I think we need to close it. Also respecting other commitments as well. So both Apurva and Mr. Chakrani, if you have questions, please reach out offline to Nishant and team, and they will forward it further. So with that, I mean, I would like to conclude the session. I think, of course, we started with very interesting development on the catalyst, on the electrocatalyst front from Mr. Gonzalo, and which went into quite a bit of technical details, I think, for the larger audience. But I think it was very essential to see the kind of chemistry and kind of details we need to get to the point what we need to go forward. And great to see your kind of contributions on that front. Also, thanks, Mr. Prasanta Dr. Prasanta, sorry, for sharing the great journey of Newtrace and also your kind of diversification into electrocatalysts. I think that's going to be very important with a lot of electrolyzer manufacturers coming up in India and providing high quality materials could be a very interesting market compared to the final end product, and great insights from Siddharth ji on what the market really needs in terms of more demand and supporting electrolyzer manufacturers. And I think for me personally, the cherry in the cake was the aspect that we are already better than China on the overall like-to-like basis, which was corroborated further by Mr. Braj in his comments as well. So with that, I would like to close the panel and thank you very much for all your time. And we will. I hope to see you again for some other time. Nishant, would you like to close it, or can we wrap it up?
No, thanks very much, Santosh. Nothing more to add. I think we've already run out of time. Thanks to everyone who've joined us and those of you who've stayed until the very end. I think it was quite interesting. And Siddharth, I think Brajnandan has been giving ideas for your business development teams. I hope someone took note of it. And I think that's also a very great point.
Absolutely.
So all well, we'll continue doing this every month. Stay connected with us. We are most active on LinkedIn, but you can always reach out to us through our website or our email addresses. So with that, once again, thanks to all our panelists and my team, Parth, Kamya, Yashashwani, the ones who've put this together, and everyone else who've joined us. Good evening, and we'll see you at the next webinar. Bye.
Thank you so much.
Thank you, Nishant, Santosh.